Hi, in the last video we discussed about the sequence, okay? Limit of a sequence. What is the limit? How do I find out the limit of a sequence, if the limit exists or does not exist? So if the limit exists, we say that the sequence converges and to that limit, okay? If the limit does not exist, then we call this sequence diverge. And also we say that how do we find out the limit of a sequence? It is same as the limit of a function, right? So we can write a function instead of the sequence a sub n. You can write a function f of x with n replaced by x in an, right? And we find out the limit of a sequence. When you find the limit of a sequence, you can use sometimes L'Hopital's rule, right? We did that type of thing. And also we discussed about the squeeze theorem. Sometimes it is hard to find out the limit of a sequence by the nth term, by taking the limit of an nth term. So in those cases, you can use the squeeze theorem, right? And then if we can squeeze that sequence between the two sequences which have the same limit, then the middle sequence, that is squeezed one, that sequence have the same limit, right? And also we discuss about the absolute value theorem, right? So the absolute value theorem says that if the absolute value of a sequence converges, then that the original sequence also converges, right? That's what it says. Okay. So by the way, on the absolute value of a sequence, in the absolute value theorem, we need that converts to 0. I forgot to mention that. So if the absolute value of a sequence converts to 0, then the sequence converts to 0, okay? So if you don't know if an absolute value of a sequence, if a sequence converges or not, then what we check is we check the absolute value of a sequence. If that sequence converts to 0, then the sequence converts to 0, okay? That's what you do. So to find out the limit of a sequence, or to check the convergence of a sequence, only one method may not be sufficient. You try to find the limit of the nth term. If that goes to some finite number, then the sequence has a limit that. If that doesn't work, then try the squeeze theorem. Sometimes squeeze theorem and the nth term of a sequence, finding the limit of an nth term may not work. Then you can use absolute value theorem. Sometimes absolute value theorem also doesn't work, and then you may have to do different theorem. So for that, let us discuss about finding the let us first discuss about the monotonic sequence, and then we'll talk about the bounded sequence. Okay, guys? All right. So let us first see, what do you mean by monotonic sequence? A sequence an is called monotonic if it is non-increasing, which is same as decreasing. Non-increasing means it is the first term is biggest one, and then which may be greater or equals to the second term, which may be greater or equals to the third term, which may be greater or equals to the fourth term, and so on, right? That is so it is like the first term is big, and then smaller, and then smaller, and then smaller, and then smaller, smaller, like that. So this is called the monotonically decreasing sequence, okay? So monotonic sequence is non-increasing. It is not increasing. It can be equal to that or greater, and A2 can be equal to A3 or greater. A3 can be equal to A4 and greater, and that's why we say AN is greater or equals to AN plus 1. This is called monotonically decreasing sequence, or just non-increasing sequence. Non-increasing and the decreasing are similar, right? Or if the sequence is non-increasing, which is non-decreasing, which is increasing. Non-decreasing means increasing, meaning A1 is less than or equals to A2, which is less than or equals to A3, and so on. And in general, AN is less or equals to the next term, right? In that case, we call the sequence is monotonically increasing, or it is non-decreasing sequence, okay? To test the monotonicity, we can check the term. You can just find out the value of each term and then see if it is increasing or decreasing, okay? Or sometimes we find out the derivative. That might be shorter sometimes, okay? Let us see some examples, then the concept will be clear to you guys, okay? First example, check if s of n equals -1 to the n is monotonic or not. So to check the monotonicity, we can list the terms and then see, right? What is a1? A1 is plug in 1 for n, -1. What is a2? Plug in 2 for n, 1. A3, -1. A4, 1. A5, -1. A6, 1, and so on. So are the terms increasing or decreasing? It is neither, right? It is just oscillating, right? It is just fluctuating. You see that? What is happening there is like this. This is n, this is an, right? So a1 is -1, right? a1 is -1, like this. And a2 is 1. A3 is -1. A4 is 1. A5 is -1. So it is just oscillating like this, right? So it is not a monotonic sequence. And obviously it looks like this sequence is not converging because the distance, so the distance between the terms are always the constant, right? You see that? The distance between -1 and +1 is 2. The distance between 1 and -1 is 2, and so on. Okay? So the distance is not decreasing. If the sequence converges, then when you go further and further, then you see that the sequence will be close to a certain number. That is called limit, right? So again, so here the sequence is not monotonic. It is neither increasing nor decreasing. It is fluctuating, right? Monotonic. Let us see another example. Is s of n equals to 4 minus 1 over n monotonic? Is it increasing or decreasing? That's what it is saying, right? What is the first term? First term is n equals to 1. It is 3, right? What is the second term? Second, that is 4 minus 1/2. That is 3.5, right? And third term, let's plug in 3 for n. 4 minus 1/3 is how much? 4 minus 1/3. So 11/3, right? 11/3. So that is the 3.6 or something, right? And continue that way. So is it increasing? It looks like the terms are increasing, right? The reason is this, because you see that when n is increasing, then this thing will decrease. When this thing decreases, then the difference will increase, right? When the term that is subtracted is going down and smaller and smaller and smaller, then this difference will be bigger and bigger. That is one way. So it is increasing, right? So it is monotonically increasing. That is one way. Another way is this. The way that I wanted to show you, that is another way, is this. That way is like this. Let us talk about that. So what is f of x? Let's find out f of x. F of x is 4 minus 1 over x. You just take that a sub n as f of x, where n is replaced by x. Now let's find out f prime of x. What do you get? F prime of x is 4 plus 1 over x square. You see that? When you find out the derivative of 1 over x, that will be -1 over x square. But there is negative sign already. So 4 plus 1 over x square. Is this value positive or negative? It is always greater or equals to 0, right? Because you see that 4 is positive and 1 plus x square will be positive always. So positive plus positive is always positive. So you see that f prime of x is positive, meaning f of x is increasing, right? Increasing. Hence it is monotonic. So s of n, because s of n is same as f of x here, s of n is monotonic. Okay, so this derivative technique of testing the monotonicity or increasing or decreasing may not work all the time, because it depends on what is the question, right? I mean, sometimes it may not work as well, because finding the derivative may not tell you whether it is positive or negative. Okay, so the next question is s of n equals to 3/2 to the n. Is it monotonic? Okay, so what do you think? It is 3/2 to the, so what is the first term? Is 3/2. I'm taking n equals to, and what is the second term? 9 over 4. What is the third term? 27 over 8. What is the fourth term? So it is 81 over 16, and so on. Do you think they are going up? It is 1.5, it is 2 point something, it is 3 point something, it is 4 point something, and so on. Actually, it is 5 point something. So it looks like it is going up, right? It looks like it is increasing. So it is monotonic here. It is monotonic, okay? But if you find out the derivative, what do you get? What is the what is the derivative of this one? So let's say that f of x is equals to, that is one way. I'm doing the alternative way, okay? This is one way here, and the other one is the alternative way, okay? So let us find out the derivative of that and then see. So what is the derivative of a to the n? It is a to the n times natural log of that, right? So it is 3/2 to the n times natural log of 3/2. What is the natural log of 3/2? It is greater than 0, right? Because natural log of 1 is 0, and anything greater than 1 will have natural log positive. So this is always positive, greater or equals to 0. Hence, f of x is, because, oh, this is f prime of x, okay? Since f prime of x is positive or 0, then fx is increasing. Okay, so this is the increasing sequence, okay? So so it is monotonic, right? That's why it is monotonic. So monotonic. So this is also monotonic. So if I give you this, if your question is like s of n equals to 2/3 to the n, what will be the s of n prime? Just finding the derivative. I'm just not letting f prime of fx or f prime of x, okay? So what will be the s of n prime? It will be 2/3 to the n times natural log of 2/3. This 2/3 is less than 1, so natural log of 2/3 will be negative. But this one is positive. Any exponent of 2/3 is always positive. Times negative will be less or equals to 0. So it is basically decreasing, because the derivative is negative, means decreasing. But still, this is monotonic, right? So this is also monotonic sequence. So now we learn how do we test if a sequence is monotonic or not. So you can list the terms and then see if they are going off. All the terms are going up and up and up, or down and down and down. Then they are monotonic. Another way is basically finding the derivative and then see if the derivative is positive for all n or negative for all n or 0, right? So in that case, you see that it is monotonically decreasing, okay, or increasing. So basically we call monotonic. So the next concept is bounded sequence. What do you mean by bounded sequence? Bounded sequence has two things we need to remember here, okay? So one thing is bounded above, meaning that if all of the terms of the sequence are smaller than some number m, that number m can be any number, okay? If all the terms of the sequence are smaller than a number m, then it is called bounded above, and that m is called upper bound, okay? Upper bound. A sequence s of n is called bounded below if all the terms, okay, all the terms are greater or equals to a number, okay? If all of the terms are bigger than a number, then we call that it is bounded below. That one is bounded above, this one is bounded below, okay? And another is a sequence is called bounded if s of n is bounded above and bounded below. If a sequence is bounded from above and below, then that sequence is called bounded, okay? So let me give you one example. Okay, so let us see first example. It says that so that s of n equals to 1/n is monotonic and bounded, okay? So you want to show both, all right? So how do we show the monotonic? You can do, what is f of x? Let's say f of x equals to 1/x. What is f prime of x? That is negative 1/x squared, right? Which is less or equals to 0 for any x, for any positive x, okay? Because n will start from 1, 2, 3, an, a2, a3, a4 like that. So x is greater or equals to 1, right? For any positive x, this is always negative. So it is monotonic. So an is monotonic, right? Monotonic. How about the boundedness? What do you think? So the boundedness will be, so this f of x is always less than 1, right? You see that? Also for n greater or equals to 1, right? S of n equals to 1/n is always less than 1. And it is always greater than negative 1 also. It is greater than 0 basically, right? You see that? So, and an is greater than basically 0, right? For any n greater than 1, it is positive also. So basically you can see that, you see that? So this is like M, you see it is bounded above by 1 and it is bounded below by 0, right? So AN is both bounded and monotonic. Monotonic. That's what we see that. Okay, guys. So the next thing is, next example is check if an equals to 3n over n plus 2 is bounded and monotonic. Do you think this is bounded or not? So to check that, you see that? So if you said n equals to 1, what do you get? 3 over 3, that will be 1, right? If you put n equals to 2, what do you get? So 3 times 2 is 6 over 3 plus 2 is 5. 6 over 5. Okay? And if you put n equals to 3, what do you get? 9 over 5. So it looks like the terms are going up, right? Because the first term is 1 when you take n equals to 1. The second term is, you see that it is, the second term is basically the 6 over 4. 6 over 4. The third term is 9 over 5. 9 over 5. The fourth term is, you see that 12 over 6 and so on. You see that this is 1, this is 1.5, this is 1.8, 1.5, 1.82 and so on. So it is increasing, right? So monotonic. So monotonic. What is the another way of saying that? If you find out the an prime, you will get 6 over n plus 2 square. So this is greater or equals to 0, right? So that's why it's also, so that's the alternative method to show the monotonic, right? Monotonic. Also, what is the biggest value it can take? What is the biggest value it can take? That's what we are saying. Let us see that n equals to, we did n equals to 4. N equals to 5, what do we get? N equals to 5 will give 15 over 7, 2 point something. How about n equals to 10? Let's see that. 3 times 10 is what? 3 times 10 is 30 over 10 plus 2 is 12. So 2.5, right? Let's say n equals to 100. What do you get? 300 over and 100 plus 2, 102. So it will be basically for whatever value of n you take, this value will be less than 3. Okay, and this is always greater than 0, right? So also you can write also an will be lesser equals to 3 and an will be greater equals to 0 for all n, because whatever value of n you pick, it will be always less than 3. That ratio will be always less than 3. Okay, guys. So what we can do here then, hence we can write hence an is both. So hence an is bounded here, because an is smaller than certain number and bigger than certain number, right? Bounded. So we get an is bounded. So an is both bounded and monotonic, right? Monotonics. For bounded, I just wrote BDD. Okay, so why do we care the bounded and monotonic sequence? There is a very strong theorem says that if you don't know, suppose if you don't know whether from the techniques we learned so far, suppose you don't know whether the whether a sequence converges or diverges. Now we ran out of any new techniques we learned so far. Suppose they did not work. In that case, there is a powerful theorem which says that if you can show that the sequence is bounded, okay, if there is a way that you can show that sequence is both bounded and monotonic, then you can say that the sequence converges. Okay, so the proof of this theorem is given in page number 595 of the book. You can look at that, but we will be using the result here. If a sequence is both bounded and monotonic, it always converges. Okay, that's what it says. Let us look at this example. This sequence is both bounded and monotonic. We saw that in example 1 here, right? The sequence is both bounded and monotonic, so this sequence converges. We know that this sequence converges from so many different methods, right? Because when n tends to infinity, this goes to 0. So the limit is 0, right? So this sequence converges. But this method also, this bounded and monotonicity also shows that the sequence converges, right? How about this sequence? Does an equals to n squared over n plus 1 converge or diverge? Okay, so what do you think? Is this bounded? Is this sequence bounded? What do you think? I mean, there are different, again, there are multiple ways to show that this converges or diverges. So the easiest way is, what is the n tends to infinity on this? So you need to use the L'Hopital's rule, right? If you find out the n tends to, if you do n tends to infinity, then you get, you need to use L'Hopital's rule, 2n over 1. So this goes to infinity, right? When n tends to infinity, this goes to infinity, so it will diverge. So what may be the reason it diverges? Because does it, if it is both bounded and monotonic, it will converge, but it will fail one of those. Okay, guys? So let us see that. So this sequence, what is the first term? A1 is 1 over 2, right? What is A2? A2 is 4 over 3. What is A3? A3 is 9 over 4. You see that? 1/2 is 0.5, 3 over 4 is 1.3, 9 over 4 is 2.25, and so on. So it is increasing. So it is monotonic. But is it bounded? Is it smaller than certain number or not? So if you keep finding these a lot of times, then you will see that it is going up and up and up and up and up. Okay? So this sequence, but not bounded. It will not be smaller than any number. If you keep finding the terms, it will grow up and up and up. In the bounded sequence, when you find any number of terms, it will approach to a number, but it does not grow up and up and up. It will, I mean, it might grow, but it might grow slowly and slowly and slowly and slowly, very, very slowly, and approach to a number. Okay, but if it grows faster and faster, for example, you see that for n equals to 3, we got 9 over 4. How about n equals to 10? You get 100 over 11. You see that? 9 equals to 4 is 2 point something. 100 over 11 is 9 point something, right? If you take n equals to, let's say, 20, you get 400 over 21. So it is almost 20, right? So you see that it will grow and grow and grow. Okay? It does not slow to grow. The growth is not slowed down. It will grow more and more and more. So, but not bounded. So all the terms of this sequence are not smaller than a number. So not bounded. So it is not. Hence, the sequence diverges. Hence, since it is not monotonic, okay, so because we know that it diverges, so a divergent sequence may have either, so a divergent sequence may be either non-monotonic or non-bounded. Okay, so and you can say instead of hence, it is better to say it this way. Also, the sequence, we know that from this method, the sequence an diverges. So the idea here is, if a sequence is both monotonic and bounded, it converges. Also, let us see another example. Does an equals to -1 to the n converge or not? So how does the terms look like? It is like -1, 1, -1, 1, -1, and so on. Is it bounded? Yes, it is bounded, because an is greater or equals to -1 and an is lesser or equals to +1. So an is bounded, right? Because it is smaller than a number and bigger than another number. So n is bounded. But the problem is, it is not monotonic, but it is not monotonic. You see that this divergent sequence was violating the boundedness. It was not bounded, and this monotonic this divergent sequence, okay, this divergent sequence, what does it do? It is bounded, but it is not monotonic. It is not increasing or decreasing sequence. It is oscillating sequence. Okay, guys. So but not monotonic. Okay, so also you see that this sequence does not converge, right? An diverges. Alright, guys, so this is how we use the monotonicity and boundedness for the convergence or divergence of a sequence. Okay, guys? Alright.